Okay.
We're on?
Yeah.
Thank you, Tracy, very much. I want to thank Tracy and Naomi Kimball, who have been working on organizing and getting us together again. As Tracy said, this is the second in a series that we hope to continue. It's really exploratory, opportunity to try to get together across the globe, really, with a number of people from a couple of different countries as well as the United States, in a conversation really about ecology and disability. And the ecology really comes from some of our work in rural communities and realizing that the study of disability in rural communities is really a study of community ecology, really focusing on the environment. Our work has really been influenced significantly by the World Health Organization's International Classification of Function, and we have been working diligently in a number of different ways, as others have around the world, to develop measures of the environment, measures of participation, new methods for measuring those factors, and new ways of even understanding disability itself. Part of what has interested me, I think in particular, in the last couple of years, has been a series of encounters and conversations with people from a broad range of disciplines that either are using methods that may apply in that way, or doing things that are addressing issues of the environment as they may affect people with disabilities, or even today, measuring and collecting data that might be able to include people with disabilities, examining portions or elements of participation that are unique and different in many ways. So we have been trying to organize and hope to continue to hold a series of small conversations with interested folks, really reaching across as many disciplinary boundaries as we possibly can. Our first conversation included Paul Lukacs from Wildlife Biology, talking about methods of tracking organisms in wildlife and trying to understand the relationship to their habitat and the ecology. And at the same time, David Gray having an opportunity to talk some of the work that he's doing using internet technology, Google Maps, and trying to get a handle on where people with disabilities go within communities and what they do when they're there and the kinds of environments they're encountering. In that process, as this past year, one of the folks that I ran into at a conference here in Missoula, a faculty member, Wayne Freimund, and I got talking with some folks actually around a conversation about protected areas or national parks in Africa. And we're talking about how they track elephants and some of the wildlife biology. And Wayne mentioned that they were collecting data on parks visitors here in the United States to begin to try to get an understanding of the way that the engagement of individual visitors, how that plays out, and was wondering if there was a connection potentially to be made with understanding potential participants with disabilities. So it is a great delight to have Wayne join us today, give us a view of what they're looking at within this kind of broad notion of engagement in wilderness and national parks, and helping us understand a little bit about maybe how people with disabilities might be included in some of that, or how we can help understand those issues. At the same time, today, Craig Ravesloot is going to talk about some of the research and development he has been leading in using ecological momentary assessment and measurement systems to track the engagement of people with disabilities here in Missoula. So I'm absolutely thrilled that the two of you guys are able to talk with us today, and I hope the conversation unfolds in an interesting way. Having said that, I think, Wayne, we'd love to have you go first and kind of give us an idea of the notion of what parks management is and what you're trying to gain and understand in the engagement of people in national parks.
Thanks, Tom.
Okay. So can everybody hear me okay? Yeah. Is that a yes?
Yep.
Okay.
I got it.
Well, first let me say thank you to Tom and Tracy who have put all this together. And do you see the PowerPoint? Everything worked so well yesterday, Tracy.
Yes, everything looks great. Keeping our line on mute for the presentation, just because we have multiple people in the room, so I'll most likely communicate with you in the presenter chat box.
Okay. Okay. When I think that's going to work out okay. Sometimes I lose the screen here, but anyway, first let me say thanks to Tom and to Tracy for organizing this and the invitation to participate. I hope that some of what I can share with you all today has some relevance to the work you're doing. I have to admit I'm very selfish in this interaction because I really want to see the kinds of things that you're doing. I think we can adapt some of your technologies and data collection approaches to make a difference. So I'm going to talk about how we've used technology over the years to help us understand national park visitors, and I'm going to focus in on that data collection piece. And for us, it's got two roles. One is to help us collect data efficiently. The other is to help us communicate with visitors and communicate with each other, with community members. That's a big part of it for us. Let me give you a little background. I've been at the University of Montana for 20 years. I teach in a park tourism and recreation management program. These kinds of programs around the country are very involved with all aspects of civil society, including people with disabilities, and programs that are trying to better understand how to integrate nature into all of society. We look at, I think, a lot of the same kinds of questions that you guys do. We're guided by generally issues of quality of life. When you think about the role of outdoor recreation, tourism, nature protection, environmental education, they oftentimes are viewed as these things that are enriching an individual, enriching a society, and whatnot. So that's really kind of where I think we have a lot of common ground to coalesce. We also spend a lot of our time thinking about how people benefit from these interactions with nature. And there's lots of reasons for that, personal growth and all of the altruistic ones, but organizations that are allocating resources and time toward provision of services always need some way to understand the impacts of their work. So we're very interested in how an outdoor experience influences a person and hopefully in a positive and quality way. When I think about our land managers, they have an additional obligation to try to provide quality services to society. They have to be able to understand the impacts of their decisions and that sort of thing as well. So that's often how they will engage people like me, is that they have a plan that's going to occur and they need help understanding how society would be affected by their decisions. So we've involved ourselves with a lot of different national park research over the years, usually in a planning context, usually when they're trying to think of a desired condition or reacting to some kind of a problem. And my colleagues would probably refer to me as an early adopter of technological tools. We have these issues of communicating complex systems amongst one another, and I was an early person in our field to jump into using computer-mediated devices to help us deal with these things. And I'm going to take you through a little odyssey of that evolution and try to end in a place that will facilitate some conversation for us. So we started out with just basically using computer-mediated imagery to both collect data and to help communicate complex situations. And I'll just show you that real quick at Arches National Park. Over time, we've tried to incorporate more sensory, multisensory kinds of things. So there's quite a bit of research going on with soundscapes, for example, or understanding night skies. And those things are really broadening the demands for technology to improve that. We also have a lot of interest in understanding where people are, where they go, how fast they get there, what their experience is like when they are there, and what their kind of evaluative reflections are after having an experience. So I'm going to take us through a series of studies that illustrate some of these things real quickly, and spend the most time on this notion of tracking visitors, radio collaring people. As my colleague over across the way here, Paul Lucas, can radio collar elk. We have the same kinds of interests in understanding movement dynamics. Okay, so one of our issues in national parks is popularity. And I would imagine most of you in this audience have been to a place where you think, wow, this is beautiful, but it's so crowded. That's a problem that visitors express to park managers very continuously. And there's been a long tradition of research to understand how to draw the line somewhere. When do we have too many people here? But what happens is that over time, people engage and they adapt and they cope with a setting with when they had a negative experience. So we used early on just Photoshop, and this is before there was a 1.0. This was just the very, very first version of Photoshop, to lay out a range of possible settings that people could see and then react to. And it was a wonderful communication tool, plus it gave us some very good data through which we could see qualitative differences in how people were evaluating settings in terms of the acceptability of the conditions that they would see or experience. And this gave us a way to get everybody on the same page when I'm talking about 100 people versus 20 people, how acceptable that would be for people to run into. This seems like very rudimentary stuff now, but it was quite a breakthrough at the time, because until then we were very much dealing with my imagination versus yours versus somebody else. And they could tell us that things weren't right, but they had a very hard time telling us what wasn't right. This removed that burden from the people we were collecting data from. These kinds of pictures were also really helpful when we would talk to community members and people that were involved with economic relationships to parks who might want more and more and more. And quickly they could see there is a potential for overdoing it on economic exploitation to where even their customers would start to experience a poor kind of experience and not come back. So, all right, and that was useful for things like crowding, but also looking at restoration efforts, targeting different kinds of setting designs, and that sort of thing. Here's a series of pictures at Zion National Park where we were looking at how people would make trade-offs for experience quality relative to access. And people said, yes, we want the trails to be this nice. And if indeed that means we don't get to go there or experience it the way we wanted to, we're willing to make that trade-off. And in this case, unfortunately, that was the original one. So the park then had good guidance to go back and make a difficult decision about access versus quality. Okay, so that was kind of our early beginnings, thinking about the world as a highly visual place. But we know that there's more to it than that, and got a chance to start thinking about some multisensory ways of collecting data. And again, we'll stay at a place in Zion National Park that is highly popular, a beautiful place. And they had just put in a shuttle system to increase access for visitors, get them off of gridlock on the roads. That created a lot of demand into the canyons, which created crowding, but it also creates kind of an echoing effect. So in this case, we did a study where we compared the number of people that you would encounter, so from this kind of crowding perspective, but also added how the sound quality would affect the visitors' acceptability ratings. So we sat in this area with recording devices, highly sensitive sound sensors, got a good distribution of decibel levels, and then created a quasi-experimental design in a lab that enabled us to get repetitions of different setting attributes that were including both sound levels and number of people in a picture. So hopefully you can hear this. This is the sound of the Virgin River when there isn't anybody there. Very, very peaceful, beautiful. And when the shuttle system was put in place and the cars were taken out, one of the first things people noticed was that they could hear the river and they could hear the birds, because the noise of the traffic wasn't in the way. But then you have human sound, and so here's a So in this case, when we looked at the data from it, we found out that the number of people in the setting wasn't nearly as important as their behavior and the sound of the people, the soundscape. And when you look in this graph, you see whether it's natural sound, a low volume of human sound, and a high volume of human sound. And then the number of people you would encounter at any given time. And the third column is the acceptability ratings. And so a high number of people with natural sound was far more acceptable than a low number of people with even a low amount of human sound. So that helps us understand the multi-sensory part of this, that we have to think about the entire, as Tom would put it, ecology of the interactions that people are having with the natural environment. Okay, and I'm sure I'm getting close to my time, but I want to show one more example. This is a typical kind of problem that I get into, where, and this is a case in Yellowstone Park, where the managers came to us and said, we feel like there's an increasing level of demand for Slough Creek, which is a really nice part of Yellowstone that kind of got found after the wolf reintroduction occurred. It's a popular campground. It's a great place to fish. And it felt to them like use levels were increasing, but they didn't have any good data on how the place was being used. And it's kind of a sensitive area, so they thought that there was a proliferation of ecological impact from visitors that might be happening incrementally over time. So this is what Slough Creek looks like. It's a beautiful part in northeast Yellowstone. And these kinds of trails occur when people walk there informally. This is a trail you can see that's happening because of fly fishing, primarily right along the stream. So we did a number of actions for them to monitor how use was happening. One was to find out how many people were there. For that, we used infrared trail counters, and we're still using improved versions of these in other parks like Glacier right now. And we needed to know how many people were there. We wanted a sense of who was there. So just through basic observations, we were able to get use type, group size, an estimate of age, whether they had any special gear like photography or fly fishing. Okay. And we wanted to know where they went. So we got them to carry GPS units with them so that we could see how their routes were working out. And you ended up with this kind of data. Let's see if this is going to work. Well, Tracy, something isn't... Oh, there we go. If you can see the movement of these data points here, this would be a composite day and have maybe 150 people going through the motion of what they did. We collected data through a whole summer, but if I put a day's worth of it kind of together, you can see how people use this area. This is the picture you saw. It was right down here in this open meadow. And we're working our way through the day. Now it's like 3 hours or 4 hours from when the day has started. And you can see how the pattern of use has worked its way through. We learned a lot just by seeing the patterns of the way things were being used. And from that, we're able to recommend to them that they had basically 3 zones of use. There was one type of visitor that just wanted to get up here and see the view and come back. There was another type of visitor that got going very early in the morning, wanted to get deep in and fish and then come back. They spent all day up there. And then there were these folks kind of in the middle. And so we were able to say, first of all, the use in the meadow is very patterned. And if you wanted to build some trails, you could minimize the impacts you're worried about. Second is that the people that are looking for solitude are getting it because they start early and they move fast and they get up there. They tend to be males over 40 years old who are fishing. So they're getting what they want. And down here, the people are also getting what they want. So we revealed that the problems weren't nearly as bad as the staff thought it might be. And everybody was real grateful. Just to have some data to communicate reality took away a lot of fear. And then we recommended kind of a zoning approach for them to think about it. I don't know if you can see these, but you got a high use zone and sort of an intensive use zone where you're going to have to do some manipulation. And then you've got a group that sort of takes care of themselves beyond that. Okay, another example is at Chaco Culture, another park we worked at, where they were very interested in maintaining access to these highly sensitive ruins. And the way Chaco works is that there's a road that comes in, and the 2 most popular sets of ruins are this one called Pueblo Bonito and this one called Chetroquetl. And there's a parking lot that regulates the amount of access that occurs to these places. And the conventional wisdom was that when the parking lot was full, everybody was going to go to Pueblo Bonito at the same time and create a problem with crowding and access. So we GPSed people again to see how they actually do use it. And what we found, here's the parking lot, is that an awful lot of people went counterclockwise instead of the way that the staff thought it was happening. So our impression of reality was different than the real world. And in fact, they took 12 distinctive routes to get to this place. They were never there at the same time. The crowding wasn't occurring. The only times that it was really crowded was when the park staff would bring in an interpretive group of 30 or 40 people at a time. So again, being able to just track where people go and how they use a place gives us a lot of information. My last one that I'll quickly talk about is at Glacier National Park, where we've been working on a management plan associated with the road. And the Going to the Sun Road is being transformed from something that looked like this to something that looks like this and brought back into compliance with safety and everything else. In the process, we've put in a shuttle system to make it more accessible, which is great. It gets some cars off the road, and it makes it available for people that don't like to drive. These shuttles are accessible to people with disabilities. And so it really is kind of a nice feature. However, it's changed the use patterns on a number of the trails that are connected to the road. So we put up a bunch of infrared trail counters to find out how many people were where, how that varies by time. And then we also put counters on the road. So now I can predict, if I know the green lines here are the number of cars going on the road. The yellow lines are when they get to the center of the park at Logan Pass. And the blue lines are how many people are on one of the key trails, the Highline Trail. And you can see a very nice pattern in these distributions. It's extremely easy to model. And so if we know how many cars are going up the road, we can predict quite accurately how many people will be on the trail throughout the day. Then we're able to ask people the quality of their experience relative to crowding, how pristine the area is, what kind of non-natural sounds are occurring, airplane overflights, encountering wildlife, experiencing solitude, and then equate that back to the number of people or the trouble with parking that they might have had as they get going. Okay? So that's an example of a series of different kinds of approaches we've used to collect data electronically in different ways to better communicate and understand patterns of use by people. We've used different tools as they become available. And right now, the kinds of app-based products enable a much more real-time, in-situ data collection process than we've been able to do in the past. We don't really need absolute real-time, and we seldom have good cell coverage. But for the visitors or anybody regarding facilities, access, drivability, all of that stuff, if they could give us data while they're actually having the experience, it would be super valuable. And we've found over the years that data is really helpful because all of us fall into the trap of whatever our basic mental model is about the way places are being used. And almost every time that we've done one of these studies, we've been quite surprised by something. There's either more use going on or the patterns of use are quite different than what everybody expected, including the scientists. So I'm looking forward to the next presentation because I really hope that we can start to learn from you how to better use some of these technologies. And we would very much like to be able to better integrate people with disabilities and their situations into this kind of data collection. That's been a really strong theme of research within the whole park and recreation and leisure studies kind of field. And so I think there's hopefully a lot of common ground. And with that, I will conclude.
That was interesting.
Yeah, that was.
Wayne, can I?
Yeah, go ahead.
Wayne, I can't tell you how just wonderful I found your presentation, and I hope we can continue this conversation. I would start off just a really quick question. There's so many observations that to me are linked. But could you talk about the importance of the use of data in management and having a receptive audience or a setting or a system to be addressing, and how information fits within the management structure?
Yeah, that's the reason they call. So I'm very grateful about this. Certainly our federal land managers, and at the state and a lot of local level as well, they function in a scientific management paradigm. They really have to be able to justify their decisions in the context of an environmental impact statement, different approaches for decision making, especially if those decisions are going to adversely affect one sector of society or another. And we often find ourselves in a situation where we can't perfectly harmonize things. We do have to preference one value over another. And so science is one way that they can come into that with a more objective way to look at the situation. Super grateful. Not every place is as progressive as, for example, Glacier National Park to include social science, but it's a language that people understand pretty well, and for the most part, they're super grateful when we can come in and give them decisions or information that will help them with their decisions. The other interesting thing that I've found is that within the management, you have very wide opinions about what you should do. And I was just in a call yesterday with a set of colleagues from Yellowstone Park, for example, and they are really struggling with how they can better communicate safety messages about bears. They have tragic things happen relative to people and bears sometimes there.
please remember to unmute your line if you do have a question, or type it into the text chat box.
Hi, Tracy. This is Billy.
Hi, Billy. How are you?
Hey, I'm doing fantastic. Awesome presentation, Wayne. I really enjoyed that. One of the things that crossed my mind in watching it is, as a person who uses a wheelchair, and we're, as Tom has talked about a lot, in measuring how communities, how people get about and move around a community. I thought that would be an awesome study to see how people move in a community. And that way you can judge, much like you're doing, where do you put your accessible features? You know, how to start your plan as opposed to starting.
Yeah, thanks, Billy. That's a great observation. You know, I think if you look at a place like Glacier, or even Yellowstone for that matter, so much of where people go is a legacy of decisions that were made a long time ago when infrastructure was developed. And so these planning moments are a chance to say, is our infrastructure even in the right place? I mean, are people going where they go just because that's where we're funneling them? Or would they really prefer something different? And I think tracking activity and movement would be great, but to be able to do that and collect evaluative data at the same time from somebody like you, for example, it says, okay, well, this is where I could go, but where I really wanted to get to was over here, and start to see gaps would be super informative, I think. So, and it's getting so easy. I bet you have a phone, Billy, and we could just turn on your DS and follow you around a few days.
Well, Wayne, thank you very much. I appreciated that talk quite a lot. I was debating between asking, is it too late to change my major, and maybe I see a new career path, or at least some kind of conjoint work ahead of us. That's awesome. I want to talk about some work that we've been doing here at the Rural Institute for the past 3 years now, and describe how we've used some similar kinds of methods and give you an overview of kind of where we're at with that. We're in our final year of the project, which is a no-cost extension from NIDR, the agency that funded the project, and we're heavy into analysis even as we speak. The names on the screen, and there are others, what a dream team of people that came together, and quite a collaborative effort from the data collection to the programming and the analysis. This was quite an effort and quite a team. So I really want to call out to these guys, and again to NIDR for the funding. So what I want to do today is give a very brief background to what it is we are trying to accomplish. Give you a sense of the methods that we use to collect the data, and then again go through some of our preliminary results from the project, and kind of give you a sampling of the kinds of things that we're looking at. Everything's preliminary at this point. We're still trying to unpack and get to some final results on these things and get some things published. But it's taken us a little while to get to this point for reasons I think you'll understand as we go along. So by way of background, folks in the disability arena probably have some familiarity with the International Classification of Function, published by the World Health Organization in 2001. They published a heuristic that was intended to show that impairments or body functions and structures are going to be related to some kind of health condition, disorder, disease process potentially. It's going to have an impact on people's activities and participation. And the personal factors and environmental factors are going to influence all of that. And so here's this model that seems to have arrows pointing everywhere, suggesting that it is clearly a dynamic model. What we're going to do is look at impairments as they've been defined in questions by the American Community Survey. And to that, one of the purposes of our project was to look at how pain stacks up with regard to impairments and participation. So we're wanting to really tease out in this model some of the influences that may be due to impairment, pain, environmental factors, with the outcome, keeping our eye on the prize, being participation. Also, by way of background, Seekins and colleagues published a nice systematic review on participation measurement, and in that suggested a typology for talking about our measures of participation, and suggested 3 different types. The first, a static measure, which is essentially a retrospective recall of a set of behaviors with very limited information about the context of those behaviors. It's just kind of what did people do. And they suggested maybe there's an interactive model as well, where you get both a recall of behavior and the environmental conditions where it occurred. And then finally, a dynamic measure, where you can measure the interaction of behavior and environment in real time in some way. So those static measures tend to be a snapshot of participation using recall, often using computer-assisted testing or paper and pencil surveys, a snapshot of what happened in your recent past. The dynamic measures are going to use direct observation, or in the case of what we did, electronic diaries, to collect data in real time to understand what people's experiences are when they're in place. So moving on to the methods, I'll tell you how we got to the group that I have some results for today. We began by randomly selecting 10,000 households in 5 zip codes in the Missoula Valley. And we sent all of those 10,000 households, which represented approximately 22,000 people according to census data. We sent them all a letter and a postcard that said, if someone in your household can answer yes to any of these 6 disability screener questions, and that person would be willing to complete a survey, we'll send you a survey. So all they had to do is drop a postcard in the mail, it comes back, and we send them a survey. The disability screeners, there are 6, include hearing, are you deaf or have serious difficulty hearing, visual, blind or have serious difficulty seeing, cognitive, because of physical, mental, or emotional condition, you have serious difficulty concentrating, remembering, or making decisions, walking, difficulty walking or climbing stairs, dressing or bathing, and finally errands, or as the census likes to call this, independent living, which we don't like to call it that, but because of a physical, mental, or emotional condition, do you have difficulty doing errands alone? Those are the questions that people could answer yes to, and then we sent them a survey in. We sent out just over 600 postcards, and 525 of those people returned a survey. The last question on the survey was whether or not they would be interested in participating in another project. And we were able to contact and collect data from 116 people between the ages of 18 to 65. And this represented a little better than 1/3 of the people who completed the survey. And the survey itself, if you look, since we sent to general population and you start to cut that back by the expected percentage of people that would have an impairment in the Missoula Valley, which is around 13%, and then you start to work toward return rates, it's a return rate somewhere just short of 20% of the eligible population that we were able to survey. And then again, the EMA group is somewhat smaller than that. So by way of demographics then, the 116 people 18 to 65 were on average 52 years old, predominantly female, white, about half were married. Nice distribution across income, so we've got about 1/4 with high school or GED, 1/3 with some college, 1/4 with a bachelor's degree, and then just short of 10% with a higher degree than bachelor's. About 1/4 lived alone, 50%, their median is between $20,000 and $30,000 annually for the family. We had 20% with income more than $50,000. 60% were non-employed, 14% approximately were part-time, and 27% were full-time employed. 44% of our sample was drawing Social Security. These are fairly close to our longitudinal survey data, and I've looked at that in comparison to census data for the area, and we're not far off, including including all of these demographics. So it looks like a nice representative sample, at least demographically, for people with impairments. In terms of these 116 people, these are the impairments that they checked. These are going to sum to more than 116 people, or 16, because people could check more than one impairment, and then average pain was collected differently. But we had 19 folks with hearing impairments, 10 with visual, 50 with cognitive, 82 with walking, dressing and bathing was 39, 47 indicated difficulty doing errands, and then 61 had an average pain that was above 4 on a 0 to 10 scale, which we defined as that's fairly close to the mean for the group, and that's what we defined as our group that had that were limited by pain in some way. The asterisk numbers for hearing and visual are there because that's low subgroup analysis, and it's to help us to remember that when we get to later results, though anything on those groups are going to be very underpowered and unstable. So for the EMA data collection itself, we brought people in groups of approximately 20 folks in each group, and gave them 90-minute training on how to use the device and respond to the prompts. We produced a very nice training manual that had screenshots that people could look at. We had training devices that people could use during the training to practice putting in entries. We went through what each of the prompts meant to help them get an understanding of the different questions that were being asked and what was intended with those. So we could put a lot more information in a training manual about what a particular prompt meant than can go on the screen of an EMA device, and I'll show you that in a minute. Then the devices were programmed to randomly prompt in 2-hour blocks between 9 a.m. and 9 p.m. And so they got about 6 prompts. They got 6 prompts a day. And then we ran the study for 14 consecutive days. The device itself prompted people to complete a survey with 25 items if they completed all of the items. However, there's some treat structure within the devices, and so typically people would be reporting on something less than that, closer to 18 to 20 items if they didn't go through every possible tree structure. We also had the devices programmed so that we could collect geographic coordinates every 5 minutes between the hours of 9 a.m. and 9 p.m. Those were primarily collected by the GPS receiver on the device. However, our whiz of a programmer also put in an alternate strategy such that if a GPS lock could not be obtained, the device would go out and look for a Wi-Fi access point, and believe it or not, all of our Wi-Fi access points also have geographic coordinates associated with them, thanks to Google. And so we were able to get a secondary data source for where people were. For people who completed all 84 surveys, then, or all of the data completely, they would have done 14 times the 6 prompts per day, or 84 surveys total. So a couple of screenshots from the device. We're using a Samsung Galaxy. This is not a plug for them. In fact, they don't make these anymore, much to my chagrin. They ask questions like, where are you? And I'll show you some more of the questions in a minute. These are radio buttons. And so presuming that people can only be in one place at one time, they pop a radio button, and in the case on the left, they're indicating that they're at home. The question about pain would be a slider. And so the person can tap on the ribbon anywhere, or they can put their finger on the white rectangle there and just drag it across. And the number above the green and gray bar changes based on what they're indicating. So they're using a 0 to 10 scale to tell us how much pain they're experiencing right now. Another option for if we wanted to know about multiple choices, one of the questions that we'll be looking at is, what are the environmental conditions that you've experienced since the last prompt? They could go through and select in a checkbox fashion any of those that they experienced, so we could collect more than just one response. So I'm not going to show you all of the EMA questions, but the ones that we're going to talk a little bit about today are, where are you? What type of activity are you engaged in? Who is with you? And then people rated their level of physical exertion, which is a 0 to 10 scale based on some work out of exercise physiology that shows that if you put the right stems with these ratings, you get a pretty decent correlation to people's heart rate. So a 10 is maximal exertion, and a 0 is complete resting. And then how much pain are you experiencing right now, again on a 0 to 10 scale, using that typical scaling that we see with pain that you might see in a clinical setting, where 0 means no pain and a 10 is the worst pain that you can imagine. Then in terms of the environmental features that we asked about, these were derived largely from the ICF, done by folks who put that together. And so we asked about which features bothered you since the last prompt, and the top one that people could answer was none, or they could suggest that they had problems with accessibility. And so we then laid out what accessibility was for people in the training manual, like lack of curb cuts, ramps, appropriate signs, allergens, things like pollen, animals, anything causing an allergic reaction, air quality or smells, smoke, pollution, perfumes, climate or weather, outside temperature, rain or snow, crowds, darkness, lights, could be bright lights, flashing lights, noisy or loud environments, loud background noise, music, voices, sounds, people's attitudes, negative attitudes of friends, family, service providers, strangers, discrimination. Room temperature could be too hot or too cold. Traffic or parking, such as congestion or difficulty finding a parking space. Car troubles, lack of a ride, bus problems would be a transportation problem. So let me show you a few of the preliminary results that we've been looking at in a few different areas in the way that we're looking at some of this data. Just again to give you a sampling of some of the things we've imagined we can do with this kind of data. Starting with environmental conditions, then I want to talk a little bit about predicting time period home, locations and activities associated with pain, and finally show you some work that's been done with looking at time geography and some mapping. This graph shows the median percentage of periods that people indicated they had problems. This is a very interesting distribution if you look across all people, because we have some individuals in the study who never had problems. They never indicated any environmental problems bothering them during the course of the study. Then we have a very flat distribution through the middle with another spike on the other end, where we have a group of people who indicated there were problems in nearly all of their response periods. This graph is showing, breaking that down then, just between differences in the median number of problems that people indicated over all 84 time periods, and breaking it out by whether they had each of the different impairments. So the green bar is yes, an individual indicated that they had a hearing impairment, and the orange bar is no, they did not. And so while that looks like a significant difference, again, we have a very low end there. And what you see looking across is that in general, if we look at the overall number of environmental problems people reported with different kinds of impairments, they're actually fairly close. The only real significant difference in this using a median test is in the cognitive area, where people who have cognitive impairments, which again, remember, have difficulty with decision-making or memory because of a physical or emotional problem, indicating far more, significantly more problems over the 84 time periods than people who did not indicate having a cognitive impairment. The other thing I should mention is that these groups are not clean. That is, a person could answer, no, I don't have a hearing impairment, but they might have another impairment. So these are not exactly oblique groups that we're looking at here. And so if we break that out a little bit further, we can begin to look at the basic hypothesis, I think, in a lot of the work that we do, which is, so do we see kinds of statistically significant differences in the kinds of problems that people indicate they have in their environment based on the impairment that they reported in our longitudinal survey. And so across the top, we've got the hearing, visual, cognitive, walking, dress, bathing, errands, again. We have the pain greater than 4, and then I added just whether or not people used equipment, in part because of what we saw in the walking impairment group. And then on the left-hand side are some of the different environmental conditions, those that were a little bit more interesting to put on a single screen. And looking at the salmon-colored boxes are showing where there are statistically significant differences, and if the hearing group is indicating a greater problem with access, then they get a GT, and if they were showing a less problem with access, it would be a less than, just to show the direction of the significant difference. And the red boxes are to show what we might have hypothesized, so that we might think that a person who has a walking impairment has more problems with access and potentially more problems with transportation. They're red because these are not statistically significantly different. In fact, these are contrary to what we would think, where we're not seeing any difference on the kinds of environmental problems that people are reporting when they're reporting that they have a walking impairment. And this then shows clearly that that cognitive group is having significantly greater problems with a number of different environmental conditions if they're indicating that if the group indicated they have a cognitive impairment than those who did not indicate such. So this gives us a sense of, at least for these 116 people over this 2-week period, where some of those differences are. A little surprising. Not exactly clear what the cognitive group means. It could mean, this is a hypothesis that was suggested by Steve Kay, it could be a sensitivity to your environment based on answering yes to that question. It could key more to the memory component of that cognitive question, such that people that have that are answering that question have more difficulties with memory, which might impact the degree to which they're able to alter their behavior based on environmental conditions, meaning you would repeat the same mistakes over and over again. Clearly an area that's worth looking at more and needs more research. So then we wanted to look at predicting time at home as a beginning place, a starting place for understanding what the effects of some of these variables might be on participation. So we thought we'd look at this. It's probably the easiest to look at just as an indicator of if you're spending more time at home, you're spending less time out. And so it's just the starting place for this. And so we start with, well, how do we know people are at home? We asked them, but then we correlated that to the GPS coordinates that were collected by the receiver on the unit. And so the GPS sensitivity was set at 30 meters, so we could get a pretty consistent lock with that. And the DFDAO used that information to create a 100-meter buffer around people's homes. And then we could code whether or not they were home or not based on the GPS coordinates themselves. Those actually correlated very highly, 0.92 or 0.93, something like that, with whether or not people said they were at home. So we have a pretty good indication that they're there. Then we begin to construct logistic regression equations to look at the effects of different variables on whether or not people are at home, but more than that, to look at not just contemporaneously, but to look at lagged effects of different conditions, in particular, what we've come down to are pain and exertion on whether or not people are going to be at home. And so one of the interesting features of the pain data in this is that there's if you look at the within subject standard deviation, there's a 1-unit variability within subjects on pain. That's basically standard deviation for that person. So a 1-unit increase represents a 1-unit standard deviation for them. And if we see that increase in pain, there's an 8% increase in the likelihood that they will be home at some point in the future. For this particular analysis, the odds ratio on pain is adjusted for all of the variables that are listed below, including age, gender, race, education, employment, equipment use, time of day, weekday, sleep, impairments, pain, intensity, that's collected contemporaneously at home. So there's a pretty strong relationship between people experiencing pain 6 or 8 hours before and then being home at 6 or 8 hours later, is the way to say that. We also found something similar for exertion, that between 4 and 8 hours later, if we see a 1-unit increase in that exertion score, there's a 5% increase in the likelihood that they're at home. But Bryce did some really nice work with this. Bryce Ward is an economist that's working with us from our Bureau of Economic Research. And he suggested, you know, people go home for lots of reasons. And so what if we looked at people going home to rest? And so this particular analysis is not quite as well developed yet. These odds ratios are just adjusted for for basically 6 lags, or the 12 hours before the observation of somebody being at home resting. But we see something quite similar, only the lag is quite different. So if you go home to rest, chances are, if you have a 1-unit increase in your pain 2 hours before, you're likely to go home in the next time period. There's a 7% increase in the likelihood for each unit increase in pain, that if you have pain now, 2 hours later, you're going to go home. The exertion is a little more lagged. The strongest lag there is if you exert yourself by 1-unit increase 6 hours before, then 6 hours later, there's a 7% increase in the likelihood that you're going to be at home. So these are the kinds of things that we're trying to do to look at the effects of pain and exertion on just going home. One of the things we want to look at next with this, of course, is to flip it on its head and to say, well, what about people who are more active and going out? But I wanted to highlight, just kind of, as we're thinking about the environment, some other just kind of interesting descriptive results. And that is, what places increase pain? where are the statistically significant differences in people's pain based on where they go. And it turns out that stores and being outside are associated with increases in pain. Gym, healthcare facilities, office buildings, these other places are unrelated. With respect to exertion, everything's related to higher exertion except for going to church or going to a restaurant in this sample. So what we're seeing is that place is related to what people experience in terms of both pain and exertion. We can also look at the kinds of activities that they're engaged in. So people's pain is increased when they indicate that they're working, doing household chores, or shopping. And again, these are contemporaneous with the activities that they're engaged in. And the exertion here is just kept in for completeness because these are all in comparison to resting. All of these increase your exertion relative to just resting at home. I'm almost done here. What we're aiming for with some of this, however, is what is the role of the environment in people's exertion? If this is an important variable, pain and exertion in headed home, one of the things that we're working toward is another pathway for understanding how the environment limits participation. And when you work with people that have pain, you hear this quite often. And that is, well, I went out and I went to Walmart and I was totally wiped out and I went home and I didn't do anything else the rest of the day. If Walmart doesn't have great access, or if it doesn't have a card available, or if people don't want to use it, the environment in some way is contributing to the exertion that is potentially sending people home. So again, these are things that we're still working toward, but with this kind of real-time data about where people are, how much they're exerting themselves, and what their pain is, we can begin to model, I think, fairly clearly, again, another pathway for how a very accessible and universally designed environment might extend participation for people because it makes it easier for them to move through it. And very finally, this is work that D.F. Dow developed. She's an assistant professor in geography here at the University of Montana. She pulled together, I think, a couple of different methods to do these graphs. These are looking at individuals who are reporting that they have pain greater than 6 during some proportion of the periods where they responded to the EMA questions. And what she's done here is, this is a map of Missoula. We've taken the street map out of this to preserve the confidentiality of our participants. But this line here is home. This is where they're at home. This is where they spend the majority of their time. And this is home over 14 days. So it's basically 14 lines lined up on each other. These show the trips that they made. So DF has used the GPS coordinates to look at when people went out. And because this is time, this is 12 hours from here to here, this shows us the basic duration of how long they were out and where they went. And so if we had all the street maps drawn into here, there are lines that show you pretty precisely where people were going. Well, this individual had 80 of 83 periods with pain greater than 6. And you can see from the key here, these dots and the size of them are keyed to the amount of pain that they're reporting. So pain greater than 8 to 10 is here, and I think actually this scale is off a little bit. I think that many of these are pain greater than 10, greater than 6, given this person's scores. And then this person had only 21 of 75 periods with pain. And one of the things we've observed, and the reason that I show these, is by asking people about their experience with pain throughout the day, we see that these people that have more consistent pain tend to have pain whether they're home or out. That is, if you have that much regular pain, you can't necessarily avoid it. You're going to experience it when you go out. Maybe there's a little relationship here. These look like these are times headed back home. So that effect that we see in the statistics might be represented here graphically, where I'm out, I have pain, boom, I head home. Not quite sure about that, but it's one hypothesis. People who had more temporary or intermittent pain tended to have graphs more like this, where they might have low pain when they're out, but rarely did they have the big pain. And if you have intermittent pain, people learn the signs and symptoms and signals of pain, and they may be changing their activity on the basis of the pain that they're experiencing. So this kind of work and what we're headed toward is to try to show graphically where people are going, how their experiences might affect that. And one of the things that Dr. Dow is presently working on is to help us visualize these in a more aggregated way, so we can look at some subgroups or across our entire sample to understand what people are doing. So lastly, just for your consideration. People may adapt their spatial patterns to minimize encountering problematic environments. And if so, then environments create behavioral patterns that limit participation. These problematic environments determine behavioral patterns that in turn, these define the social problem of inaccessibility. We can begin to show these. Because if people adapt and don't go particular places, we can now show graphically where the problem is. And finally, is the effect of the environment on exertion and pain another pathway for understanding accessibility and participation?
Great. Thank you, Craig. That was great. And at this point, we are going to open it up for more discussion. You can begin by specifically asking Craig some questions about his presentation, and then also more broadly going back to Wayne's presentation as well. And Tom, you may have some opening comments as well.
Yeah, Craig, this was just fantastic to see the work coming together, and thank you very much for putting it together and sharing it with us. I saw so many connections with Wayne's presentation, but the last one, I would just ask maybe if you would comment. Wayne had talked about how the creation of the historical infrastructure in some of the places had made some predetermined decisions, and you commented about how environments may be problematic designed environments. Could you comment, do you see a connection between that and?
You know, I think that the problematic environment is clearly an inaccessible environment we all define as a problem. I think one of the connections that I'm seeing to what Wayne is doing is that I think that we're going beyond that in some ways to look at an environment can be problematic because of noise. An environment can be problematic because of traffic. And we all know the places in our hometowns where traffic can be a problem, and we avoid those areas. And so the infrastructure creates the problem to begin with. We then adapt to them and figure out ways around them. And I think the connection is probably around universal design on the one hand, but also around information that helps people to recognize the impact of the environment on their behavior and their patterns. I think I'll stop there.
Thank you. It looks like Steve K. has a question for you, Craig. I'll just read it. Craig, how could you go about confirming your hypothesis that it is the pain that sends people home?
Well, for one thing, what we've been trying to do, thanks Steve for the question, we've been trying to rule out other possibilities. And so if you look at just the amount of time that people have been out, or whether it's a weekday or a weekend, or just fatigue in general, we try to take the data that we have and rule out other features of it. And so what we've seen in that, and what I tried to show real quickly in that slide, was that with the things that we have in our data file, our lag results on pain are very robust at kind of 8 to 10% increase in likelihood for each unit increase in pain. So I think for even this kind of longitudinal EMA data, it's still observational, right? So we're not going to have the control or the ability to change pain and watch that effect. But perhaps we can do things that change the environment that would have an effect on pain and exertion, and look for effects on the other end in terms of what people participate in. We were just talking about that this morning in a meeting. So if we did a random assignment of improving and increasing the available carts in Walmart, and then follow people throughout the rest of the day, we might be able to vary the environment in ways that allow us to look at future participation based on a reduction in exertion. That's just one that came up today off the top of my head.
Great, thank you. And it looks like Gail Whiteneck is typing a comment or a question. As we wait for that, I welcome other questions and comments, either from staff here at RTC or attendees on the call.
This is Gail. I'll just ask my question. The when increases, as you were showing us, X number of hours before returning home, does that maintain itself until the person gets home? Does it, or does it subside? And is that a predictor of whether they actually go home or not? And is the pain less at home?
That's a great question, and I'm going to have to think off the top of my head about those correlational results. Pain is less at home is what I'm remembering off the top of my head. Now, we don't have those results built in yet that look at, okay, so you're out, you have more pain, you go home, your pain reduces. What's the time frame? What are the lags now for going out and participating again? We're not there yet. But if I understand your question, the contemporaneous relationship between pain and being at home is that you have less pain at home.
Thank you. I guess where I was headed was if you have a spike in pain, but 2 hours later you aren't yet home, but it's subsided, is that a predictor of not going home? And if it's still there, a predictor of going home?
And so
I'm not quite understanding the lag that you have.
Right, and that's actually an interesting part of the lag itself, is that it's just that crude. It's just looking at that kind of 2 hour when we're looking at resting at home, or that kind of 6 to 8 hours if we're just looking at home, and it's crossing days. We literally are just saying here's the 84 different time periods, and we're looking at lagging back those 2 or 3 lags, and those are just the overall results. So what happens in between, we don't know at this point.
Lots to study.
Craig, this is Meg. I just wondered if the exertion scale has been validated in populations experiencing that level of pain, and whether there's some opportunities just to incorporate some things like Fitbit into this kind of study design to get some of that convergence with ratings of exertion and heart rate. Yeah, you know, the Galaxies and the smartphones all have accelerometers built into them, and it was on my wish list to collect that data as well. But this project had gotten big enough. We actually didn't propose the GPS as part of our data collection to begin with. We proposed to use iPods, but as we got further into it and realized that the Samsungs included the GPS receiver at that time, we switched to that device. So as far as the exertion scale goes, and populations with pain, I don't have a hypothesis for why it wouldn't be, but I can't point you directly to that resource that would suggest that that exertion scale works as well in a group of people with pain.
I have to ask this question. This is Tom. Wayne, one of the measures that you collected had to do with something like the spiritual, aesthetic experience that of peace and harmony in the parks, solitude, and kind of almost a sense of healing the soul. And I wonder whether we could explore the relationship between the experience of pain, excursions into natural lands, and that kind of sense of healing, how that might fit together, if it does. And Craig, I'm curious what you guys might say to that.
Thanks, Tom. I can comment on that line of research. It's the whole kind of getting grounded, spiritual connection, moving away from the typical distractions and trappings of the environment that Craig just described, is a very consistent theme in the way people talk about experiences in parks, and particularly in kind of these big, impressive national parks like Glacier. There's a very deep kind of sense of connection that happens, and it can be transformative. It's the sort of thing where people go there and they decide to change their jobs, or they decide to move to a different place, or they, have that moment of reflection about their life that large decisions come from. Change majors in college. Craig, you're welcome over here anytime. Go to Glacier and we'll recruit you from there. So there are actually scales that have been developed and kinds of questions that approach this sort of thing. It's a difficult thing to manage from a park manager's perspective, but it's a great qualitative way to talk about the depth of the meaning of these experiences in these places.
And I would just add to that, take for example the boardwalk that goes up to Avalanche Creek in Glacier National Park. I have always viewed that as a basic accessibility feature for people that use wheeled devices, and have not really considered how that deals with the problem of uneven surfaces on trails that allow people to go back and see Avalanche Creek, and how that comes out without the high exertion that would be a problem for a lot of people. I think that part of our data and part of the American community's questions on things like you have serious difficulty walking or climbing stairs are picking up a lot of people with pain that don't use equipment. And so for them to have a walkway that doesn't that reduces their exertion, this would be could have a very high benefit for their quality experience, I would think.
That's a whole new layer of thinking about this, Craig, that I think would be really valuable. When you look at a place like Glacier, there really are only a few accessible trails that are designed that way within this 1 million-acre park, and that isn't unnoticed by the management staff. A lot of it is legacy and zoning and things like that try to curtail more development. But it's a tough place for people that need assistance with a wheelchair, for example. There's not many places you can go. So yeah, that would be a great rationale. And with our society aging, park visitors are aging considerably. The average age of the visitors up there is similar to your study, pretty close to 50. And we're seeing fewer young people. The baby boomers are coming. They're going to, I think, have a lot of these concerns.
And thanks, Wayne. And this is Tracy, just to follow up those comments. And you may have addressed it in part for Bob Liston, who asked the questions through text chat. He says, Wayne, do you see the parks taking into consideration accessibility issues on new paths that are put in? They don't necessarily need to be boardwalks or paved. And are you doing anything to address Billy's issue about where we might want to go rather than where we can get to? I hope this makes sense.
Yeah, that's a great question. It makes total sense, Tracy. They are, so when you do a plan for parks, at a minimum, they have to think through ADA kind of considerations. They are genuinely interested in who the audience for the parks are, and to be as accommodating and, regardless of whether it's age or gender or international or people with disabilities. These plans are the times when those things get developed. I think the big issue that happens with a place like Glacier, and which may make it a bad example, is that there are so many different kinds of demands. People want more biking on the Going to the Sun Road, for example, and people want more dog walking on the Going to the Sun Road, and there's so many people that are invested in the place that they want a lot of everything. So I think there's a tendency to just back off and say, you know, and then there's a lot of people that want no change at all. Okay, so there's a tendency to be conservative in their development. But I'm sure of it in this case that they're thinking about, if we have limitations within the going to the Sun Road corridor about access or vehicle types or alternative mobility types, where else in this park or in this kind of part of it can we design some things that are going to be much more available to society? So yeah, it's in the discussion, but these plans are kind of political documents. I think the advocacy groups that are going to make sure that people with disabilities concerns are heard loud and clear need to be involved in the planning process and need to be commenting on alternatives, and I think I've seen that have a big effect as well.
Great. Thank you, Wayne. Another question from Gail Whiteneck. Wayne seems to conduct studies in order to make an interventional decision. Craig, what thoughts do you have about designing your research to help facilitate interventions?
Yeah, thanks, Gail. Appreciate the question. We've kind of thought about that in a couple different ways. On the one hand, the kinds of maps that Wayne showed that were great. I love the moving map showing where people traveled. I'd like to learn that technology because we can show at a systems level where people go, and we could show people with different characteristics and we could show in real time where the barriers are, where they just don't go. So that kind of mapping and data could be used at the systems advocacy level to build out the infrastructure that's more accessible and less problematic. I like your inclusion of noise, which bothers some people a lot more than others, and it's a problematic environment. At the individual level, I think that there's opportunities for education. That is, if a person just makes the personal choice that I don't want to use wheeled mobility at Walmart because I don't want to look disabled, the education to help them understand the trade-off, which might be in terms of social or recreational or other kinds of quality of life activities that they might do later on in that day, is part of their trade-off as well. That may be a message that would be useful for people to hear. And then finally, this kind of interactive technology has intervention written all over it. And so pacing is an important part of treatment in pain so that people are not doing too much activity that triggers that pain. And so these kinds of methods could easily become ways to help people monitor exertion and to pace their activities a little better and avoid some of those spikes. And that's one of the real difficulties in pain treatment, is getting people to gradually increase their activity level. And this kind of monitoring device could certainly help them do that.
Great. Thank you, Craig. Go ahead.
Could I just throw in a kind of an addition to that? I think what Craig showed us is a really kind of a game changer in the way that I think about this. Just knowing how time lags work, because we tend to catch people at a snapshot in time, even in a diary sense. And so now not only can you look at how geographic distribution is happening spatially, but you can think about it in terms of cause and effect with different experiences. So I would love to know, for example, how running into a large crowd or the inability to park, for example, at Avalanche, which is one of our big problems. You know, it's a great trail if you can get there. So if you drive there at 10 o'clock in the morning and you can't park, what do you do next? Or do you come back and adapt? So tomorrow I'm coming back at 9 in the morning. And we just aren't able to capture that sort of stuff very well yet. But you're showing me that the ability is right there. So if we could merge your understanding of time lags with mine of geographic spatial stuff, I think we'd really be able to do something great.
Great. Thanks, Wayne. And Christian, do you want to pose a question? It's not coming through, so you can type it as well. or comments, or just make sure that you're unmuted. And then as we're waiting for Christiane to type out her comments or question, I realize we are almost half past the hour, which is when we're scheduled to finish this discussion. For those of you who need to go, just thank you for your participation. We will have a recording of this entire seminar available in the near future, as well as a transcript. You are free to sign off, and we'll make sure you get those connections. For anyone else who'd like to continue with this discussion, please feel welcome to stay on the line. And also, if you have other questions, other people have questions while Christiane is typing hers out, please submit them.
I just had a quick question. This is Meg Tracy for Wayne about the infrared sensors and your ability to estimate age and detect gear. Are you able also to detect whether somebody's using a mobility device like a wheelchair or a hand cycle on the trails?
Yeah, there were two parts to that particular study. One was a human observation. So that's how we got age and activity style and that sort of thing. So the infrared counters will just tell you a number. You know, it was broke up this way or that way. You could, in some situations, use the kind of counters we use for cars, which are magnetic. And so if you put a magnetic counter onto a trail, it would at least be able to tell you if it was a bicycle or a wheeled device. You wouldn't know which. Now, there are other things that we've done, like used camera traps and blurred the focus so that you're not seeing an individual in detail, but you can tell whether they're carrying a backpack or not. You could tell if they were on a wheeled device or not, and get an estimate.
Great, thank you, Wayne. Okay, and it looks like Christiane's comments came through. So she says, thanks for 2 great presentations. Wayne, I was struck by your findings on crowding. Fears of crowding were unfounded as visitors found ways of distributing. Is this a new finding? I may not have read that correctly.
Yeah, we have a very interesting. Thank you, Christina. It's nice to see you typing. It's been a while since we've talked. We have a very interesting history with this crowding issue. I mean, some places like Arches, where I started, it's highly apparent, and people will complain about crowding as a major issue for them. In a lot of other places, the people that manage the area may actually have a higher sensitivity to crowding than the visitors themselves. And the visitors, as Craig, I think, very aptly laid out, have done a lot of adaptations before they get there. If you go to Logan Pass on an August day, if you're from Montana, you know it's going to be crowded, and you've still chosen to go there. So you've either in your mind decided another goal is more important, like showing Logan Pass to my family, or you've decided that another experience, maybe bonding with my family, would be more important than solitude. So we see that happen quite a bit, and I do see a difference in the way that people with long-term attachments to the place, like managers, feel about crowding compared to visitors. There's usually 30 to 40% will show up very consistently in studies around the country. 30 to 40% of the people will, on a scale of 1 to 9, feel crowded above a 3 or a 4, much like Craig has laid his out. And it's a substantial number of people. I mean, if we think of Our national park system gets about 250 million visits a year. So if 30% of them have an issue, that's a big number of people. And so it should be taken seriously. But in any given context, it may be more or less of a big deal.
Well, and just to comment on that, Wayne, I can imagine helping people tailor their experiences based on some self-assessment. You know, it would be fairly easy to put together an app that says, hey, what are your values in this? Are you looking for solitude? Are you looking for the, you know, the common experience? Do you have to go to Yellowstone Falls because that's where you're going to find a lot of people, or do you need something different? And if it's family bonding, you might be able to tailor people's where they go based on what some of their values are. And I think we can do the same in our work in terms of community work and how people access community and choices that they make that have trade-offs in terms of exertion and potentially pain.
Yeah, very, very good point. I had written that down when you were talking. One of the strategies for management that we've talked about quite a bit now that we have this data is to share it with the visitors so that they can make an informed choice. If we show them our use level graphics or time it takes to park at Logan Pass on a busy day and tell them, you know, if you go there now, this is what you're going to get. If you wait 4 hours and go, it'll be very different. You choose depending on how much time you have and, you know, how important it is to you. And I think they will redistribute it quite a bit. But again, we need something to communicate with them, and so the data is a really, if we can make that digestible, that's a nice thing to have. I'm sorry, Tracy.
This is Meg. I just wondered, in terms of these negative subjective ratings, are they in any way correlated with negative environmental impacts? Do users have this kind of intuitive sense that this crowding or other things like noise really is impacting the wilderness?
Very much so. You know, visitors to a place like Glacier, you know, like a community, have a wide range of sophistication in their way of assessing a setting. And some are very astute wilderness advocates that will think about, like the sound from Harley Davidson, for example. They'll think of it in terms of their own experience and whether it was annoying or distracting or preventing them from cutting the rope with society and actually getting this spiritual restoration that they want. But they'll also think about it in terms of the cumulative effect it has for the idea of wilderness, for wild things in general, for the pristine quality of the place, for the ecological impacts that could happen as a result of that sound intrusion. So you have some folks that are way out on that end of the continuum, and then you have other people that really, they're walking up to Avalanche Lake and on a 10-foot wide trail with roots exposed and trees hammered, and they think it's the most beautiful place they've ever been. They don't see it at all.
And that highlights the role of personal factors. And that's been one of the surprising things to me, and just asking people a question, what have been the environmental conditions that have bothered you? And to see the distribution where for some folks, you know, nothing bothers me, it's all right. For others, everything bothers me. And there's quite a lot, I think, in terms of intervention that can be done in that as well. And I think unpacking and teasing some of that out may be an important part of intervention too, just back to your question, Gail. I think there are things that we can do as clinicians that help people to develop a little more tolerance for things like noise and traffic that can increase their quality of experience in a lot of different places.
And I'd also add, Craig, that a sense of power, that you have some impact, you have some ability to impact the environment, you know, and just thinking about some of your comments, Wayne, and how that would translate to people with disabilities in terms of their perspective and power to be an advocate for changing the environment, and how they would potentially rate their experience either from a very personal or individual perspective, or thinking about the community's accessibility broadly for the community.
Yeah, Meg, that's a really interesting intervening variable in this. When people are not empowered, what does that mean for your experience of the environment? Very insightful.
Well, I I want to thank both of you and everyone else for just a fascinating discussion this morning, and very grateful. One of the things Tracy and I would ask of folks, if you've got suggestions of topical connections that we might make in the future, let us know. Having said that, Wayne, thank you so very much. Craig, thank you so very much. And I think we're going to try to have another one of these sessions probably in February. So Tracy, thank you.
Mm-hmm. Yeah, thanks everyone. We will end the session now. If you have any questions or comments, you can email me directly. I will put that up on the screen, but feel free to sign off. Thanks everyone.
Thanks, Tracy. Appreciate your organizing this. It's been great.
Yeah, me too, gang. Please keep me on the mail